started.
Perfect. Awesome.
All right, excellent. Thank you for coming out, everyone.
Everyone. Sorry about that.
Yeah, no, we're good. We'll get this right. Excellent. So, just wanted to take a second and kind of introduce ourselves. My name's Eric Roy. I'm the founder and chief scientist at HydroVive. Analies, do you want to go ahead and introduce yourself to the few people that may not know who you are?
Yeah. So, my name is Analies, and I recently got my master's from GW in environmental policy. So I'm kind of HydroVive's head of policy. So I just keep track of all news, legislation, anything regarding drinking water.
Excellent. So the reason why we're doing these podcasts and these Instagram lives is to really dig in a little bit into some of the newest studies that are out there, just so our audience can actually have access to the best studies. Because the reality is studies tend to move slowly, so we're keeping our finger on the pulse here. So today, our specific topic today is to talk about Pfas. This is something that we've been talking about on our website. It's what's categorized as an emerging contaminant by EPA and by these state agencies. And it's probably, Analies, correct me if I'm wrong, but this is the topic that our science team gets the most questions about, like on live chat and email, right?
Absolutely, by far. People are so interested in Pfas just because it's so present everywhere.
Yeah, in the media, it's pretty present. And scientists, I've been working on Pfas for over a decade, and there are some that have been working much longer on Pfas, but it's finally starting to get a little bit of media attention, which is why we want to talk a little bit about some specific health outcomes that we know as the scientific community actually understands really well. Today, we're going to be specifically talking about the impact of Pfas exposure on pregnancy. Again, Pfas, so we're getting a couple questions about what are Pfas. Pfas are a type of chemical, the acronym stands for per and polyfluoroalkyl substances. It's just a lot easier to say PFAS. Pfas, some people have different ways of saying it. And basically, these are chemicals that are found in firefighting foams. If you remember the old Scotch Guard stuff that people used to spray their couches with and rugs and stuff like that, they're really, really useful chemicals. They prevent stains, they prevent sticking on nonstick pans, but it turns out they're really toxic. And that these contaminants, they don't break down in the environment, and they can contaminate drinking water. So when you're drinking the water, it can kind of go in your mouth, and then, as any toxin that works its way through its body, there are negative outcomes of that. So today what we're going to be talking about specifically is how these chemicals, so there are two specific studies about how this category of chemicals impacts pregnancy. So Analies, do you want to just kind of get right into this? What specifically are we going to be talking about today?
Yeah, so like you just said, we're going to be talking about two specific studies, one out of the University of California, Berkeley, and one out of Yale University. And both of these have kind of emerged as the best available science that we have right now on how Pfas impacts reproductive outcomes and pregnancies. So I can start with the Yale study, and we'll just kind of get into what some of these health outcomes actually are. So this group of researchers from Yale this year in 2020 looked at a cohort of 400 women. 200 of the women, their pregnancies ended in miscarriage, 200 ended in live births. So of the 200 of the pregnancies that ended in miscarriage, they had higher levels of Pfas in their blood plasma than the 200 who ended in live births. So from this study, the Yale researchers were able to conclude that exposure to Pfas increases your risk of miscarriage by 80 to 120%. So this is a really, really powerful number, and it's pretty jarring. So, yeah.
I think that's... Let me just ask you just a quick question, Annalie. Yeah. So on the statistics for this, there's correlation, right? And then there's causation. So correlation is kind of a lower bar. It just means that there is an association between, in this case, Pfas and pregnancy outcome.
Right.
Were the Yale researchers able to demonstrate causality? Causality is kind of a higher statistical bar that shows this caused this, which is
Right.
statistically stronger
So,
than
you know,
this is
just
associated
because,
with this.
yeah, so just because of the scope of this study, you know, they were only studying 400 women. So they weren't able to conclude causality, but correlation and association, absolutely. And again, 80 to 120% is statistically significant. So it's really important that, you know, this study,
Yeah.
just because of the limited size, isn't taken for granted. Like, this was a
No,
really,
no, no,
really
no, no. In fact, it's usually, it's kind of one of those things in science where you look for fire where there's smoke, right? And I think this is a really good example of, like, this is something that I don't even want to call it preliminary data, but these statistically significant data are things that we need to be prioritizing. I'm sure the Yale researchers made the case that we need to be studying this more with much bigger cohorts.
Yeah.
Okay.
Yeah, and I can get into the University of California, Berkeley study, which was a much...
Okay, so we're changing gears and we're now talking about that study from Berkeley, right?
Yes.
Okay, cool.
So this was a much larger study group. It was 48,000 women. And the Berkeley researchers studied this over a long period of time. And they were able to determine that when water filtration was introduced into this community where there was a lot of PFAS in the drinking water, fertility and birth outcomes actually improved. So they were able to determine that when water filtration was kind of put in place in these drinking water treatment facilities, birth outcomes improved by 30%. So, you know,
wow.
this study it's a bit more robust than the Yale one, just in terms of how many people they were actually looking at. And what's really interesting about this Berkeley study is that they actually were able to determine causality. So they were able to determine that exposure to PFAS was actually causing these reproductive challenges and these lowered fertility rates, low birth weights. So yeah,
wow.
The Berkeley study was a landmark study in terms of PFAS and its impact on pregnancy.
So in this study that Berkeley did, who were they targeting? Like, who, you had mentioned 48,000 is the sample size. Yeah. Were they targeting people that had known levels of PFAS in their water? Or who were they targeting?
The study was in Minnesota, and if you're not familiar, there was a really big lawsuit that happened a few years ago because PFAS was such a big problem from this one chemical plant. So these researchers looked at a suburb of the PFAS chemical plant, and they were able to look at 48,000 women. And so this was a really, really important study, and it was really crucial that it was done, just when it was, because now we have those data to kind of move.
This plant, if I'm not mistaken, was actually involved in a giant settlement, right? Like, I think $800 million or something, but they didn't.
Yeah.
But they didn't. But they didn't admit guilt, right? They just settled. Settled for almost $1 billion just in Minnesota.
Yeah.
But they did not. They didn't. No guilt, no fault, of course.
Right. But. Yeah. But then from that lawsuit, researchers from all over are kind of like, I wonder what else we can determine from this lawsuit, because that's a lot of noise. $800 million is a lot of noise around a community with high levels of PFAS. So,
and again, in one state, right? Like that was, and I think if I'm remembering correctly, in that settlement, their whole thing was, we're not admitting any kind of guilt associated to human outcomes. We're just talking about environmental cleanup stuff, right? So that's one of those that kind of made my skin crawl. I cringed a little bit when I read that.
Oh, that's a really, really good question that someone just asked. Eric, if you want to.
We use sink water for cooking. Would PFAS chemicals be present in water after it's boiled? Yeah, so boiling water does not remove chemical contaminants. Boiling water is used to kill pathogenic bacteria. So boiling your water is not going to do anything to break down PFAS. These chemicals are pretty bulletproof. So yeah, that's a good question. We'll talk about that in another podcast, I think,
Yeah, no,
because
it's a really
huge
common
thing. It's
misconception.
super common.
Yeah,
Yeah.
yeah. So boiling water is, yeah, just to kind of wrap that up, it's just biological
Yeah.
contamination. So like E. coli or other things that might be present in water that are alive, but heavy metals and chemicals,
Uh,
you can't remove them through
you
boiling.
don't remove it by boiling.
Yeah.
Excellent. So I guess back to these studies, Annalise. I mean, when we're looking at preponderance of evidence, right? And when we're looking at these things, we always look at new studies in the context of what's been done before. It's that concept of, standing on the shoulders of giants. Now, are there a lot of other studies that have really dialed in this, where they're looking at the impacts of PFAS on this, or is this something that it's kind of on the leading edge? Where are we in that research cycle?
Yeah, so we're at the very early stages. This is not a sprint, this is a marathon. So, these two studies are just a couple of a handful that are even available right now. So, a lot of the preliminary research with PFAS, they were just drawing kind of like nebulous associations between cancer and increased cholesterol and nothing really finite, but these two studies in particular are the kind of the first of their own. And we expect to see a lot more, in 2020 and the coming years, just around this topic of pregnancy and its association with PFAS. So we have a lot more to come, and there's just not a lot of research available right now.
So, I mean, even aside from the epidemiology studies and the policy work, I think I can speak a little bit to some of the work that we're doing on PFAS internally at Hydroeve, and it really just speaks to what you're talking about, how we're on step one. We've been doing PFAS filtration since the company started, and one of the things that we've really, really been struggling with is actually finding labs that can generate quality data on this. So in the very early days, when we were working on this, we took PFAS samples, split them among 10 different labs and just that claimed that they could actually quantitatively determine PFAS, and sent them as blind samples out to these labs. And we got, I think it was like 100 part per trillion sample. We got results back from non-detect all the way up to like 1,000 parts per trillion for the exact same water. So, I mean, Hydroeve started 5 years ago. And when we were doing this, like these round robin kind of blind trials that we were doing, it was just really discouraging to see that a lot of these labs were having a really, really hard time generating quality data. And what's been really, really fortunate is the academic community has actually stepped up in a major way here. And particularly the work that's happening in North Carolina right now. Duke University and NC State, professors at both those universities have kind of said, look, we want to actually provide data to people that they can use to make decisions in their everyday life. And what these universities did is they actually evaluated water filters against PFAS chemicals, both Duke and NC State, and then kind of combined study. And the results were pretty all over the place. Some filters did really well. We're fortunate to have been in that category. Other filters didn't do anything. Some of the big names that you see on the shelves at your local big box store, for example. We're not going to name them here, but Annalise, is that article like in our profile right now? Like if you're actually looking for a filter that removes PFAS?
Yes. Yep.
Okay.
Yeah.
So yeah, sorry, we're a little bit kind of off track here, but we just want to kind of bring it back, lump it back into some takeaways for people that are listening today. So what are those takeaways for people that are either pregnant, thinking about becoming pregnant, or maybe has a friend or family member who's looking at this as well?
Yeah, so we just kind of scratched the surface of these health outcomes. So all of the information that we know and that's available is going to be in our link in Instagram. And we just go really into depth about some of these negative health outcomes with pregnancy and PFAS. So again, increased risk of miscarriage, lowered fertility rates, low birth weights, and just really overall impacts on reproduction. I think second, in the Berkeley study, they were the first of their own to kind of determine this direct causal link between exposure to PFAS and, you know, pregnancy outcomes. So they determined that when you introduce water filtration, the pregnancy outcomes improve. So it's important, like Eric was mentioning about the Duke study, it's important to make sure that the filter that you have actually does remove PFAS. There's a lot of noise about certain filters claiming things and not, but you know, it's important that you make sure that the manufacturer has third-party data and that they've really tested their filters against PFAS at different levels.
And let me just kind of chime in here just for a second. If you're talking to one of these manufacturers, make sure they didn't just performance test the first gallon of water. That's one of the dirty tricks of, you know, the marketing tricks in the water filter world is, you know, these companies will show really, really strong data, but it's for the first gallon of water. So if they say that their filter removes, you know, has a capacity of 6 months or, you know, 600 gallons or whatever, ask to see data, ask to see test data out to that number. Because I think you're going to find a lot of companies, when you ask that question, they don't provide those data.
Yeah, and then, you know, finally, we want to hear from you guys. We want to hear all of your questions. This is a really, any misinformation surrounding PFAS? Great question.
Oh, there's just a ton. It's crazy. I think, Annalise, it's rather than just kind of go down the rabbit hole here, would it make sense just to put a bunch of those links in our profile?
Yeah,
like
so
there's just so much garbage.
I'll have a bunch of information in our link tree on our profile. So yeah, we'll see you guys.
I guess
next
that last
week.
bullet point. What were you saying?
What?
Yeah. So how can people submit the next question for next week when we dig down a little bit deeper?
Yeah, I mean, you can DM us on Instagram, messages on Facebook. hello@hydroviv.com is our email for support. So that'll be sent over to me or whoever, and we'll definitely be sure to answer those next week. So
yeah, we want to talk about things that people care about. I mean, we could talk about things that are interesting to us, but I think we're probably a little bit nerdier than what the general public wants to hear. So but yeah, I guess that's it for today. We're kind of up against that 20-minute mark where we like to stay under. So I just want to, you know, just finish up by saying, you know, thank you, Annalise, for digging into this for us, and then thank you all for listening. Reach out to us if you have any questions. That's what we're here for. Have a great day, everyone.
Thank you. Have a good day.